But this I don't want first. Okay, tell me, where did we stop in the last class? Last class, अच्छा नहीं लास्ट क्लास में कहाँ पे रुके थे हम लोग मतलब हो गया था कैलोरीमीटर में प्रिंसिपल ऑफ कैलोरीमीटर कर लिया था फर्स्ट यूनिट कंप्लीटेड फर्स्ट यूनिट का न्यूमेरिकल लॉ किया ना हाँ ठीक है तो विल कम टू न्यूमेरिकल्स लेटर पहले मैं यूनिट बी करा देता हूँ ठीक है If we do natural phenomena and consequences, but calorimeter का वो जो फॉर्मूला था वो हो गया? So the way I do this part is like you will take turn in reading, right? The title, then I'll explain it. So this is the natural phenomena associated with consequence of high specific heat capacity of water. So first of all, tell me what is if I say a substance has high specific heat and the other substance, what does it mean?
So that means the high temperature required to meet the temperature of needed molecule.
Can absorb more heat. High temperature is required. More heat is needed to either increase or decrease its temperature. So please don't now. By now, you should be very clear what is the difference between heat and temperature. Is there anyone who is not yet clear about what's the difference between heat and temperature?
Yes.
Huh? Clear? What's the difference? Can you tell me?
The heat energy होती है और जो determine करती है कि कौन से direction में मतलब hot से cold बॉडी.
Anybody else? Direction determine करता है temperature.
Temperature direction because heat when it moves from one cold hot body to a cold body.
Yes. So heat energy move करती है hot body से cold body में. जिस body का temperature ज़्यादा होता है, उसमें से heat energy cold body में travel करती है. ठीक है?
The heat is different from kinetic energy and potential energy.
Constituent particle जिससे वो substance बना है. ठीक है? तो हीट एनर्जी उन सबका टोटल है काइनेटिक और पोटेंशियल एनर्जी ठीक है और टेंपरेचर किस पे डिपेंड करता है काइनेटिक तो ये चीज समझ में आनी चाहिए अभी तक ठीक है ओके तो पहला वाला जो कॉन्सिक्वेंस है यू रीड विल टेक टर्न्स
The climate near the seashore is moderate. The specific heat capacity.
Just read the title. So understand the title. The climate near the seashore is moderate. Is the climate away from the seashore moderate? No. Like if you go to Pune, you get hot and cold climate. But in Mumbai, do we have hot and it's moderate. So all over the country it is winter, but in Mumbai we don't have winter. We don't have market.
Yes.
Okay. Market. Oh. It's moderate. Okay. So this has got something to do with high specific heat of water, correct? So high specific heat of water has got something to do with it. There is a very common tendency where you have to write heat, you write temperature. यहाँ पे temperature लिखना है और heat लिख के चले जाते हैं. So first you be very clear about heat and temperature. ठीक है? So we are studying consequences of this. So first is moderate. अब देखो yes, let's say this is sea beach. All right, and this is your sea water. Okay, let's understand with this diagram. Now both are getting rays from sun. Okay, in the daytime. So this is the scenario in daytime. So in daytime, what happens? Now sea beach has low heat capacity. The sand part of it, sand or land, whatever, low heat capacity, low specific heat capacity. What about water? High or highest, right? Highest specific heat capacity amongst natural substance. So same amount of irradiance or exposure to sunlight will make sea surface very hot, the sand surface. So this will become hot, right? Whereas it will not be so hot. It will remain, means it will absorb so much of heat, yet its temperature will moderately increase, right? So if you compare the air, so air here and air here, air which is in contact with the land will be hotter. Okay? This will be, with respect to this, cooler. It's all relative, right? The only thing is because it is not as hot just walking. So what will happen then? What about hot air? What about density of hot air? Expand. Yes. So density of hot air will be less. So it will rise up. So now there is a vacuum created. So this will fill in. Right? So this is how a convection current, air current will set up. So during daytime, when the weather is supposed to be hot, okay, so then you will get sea breeze. You get sea breeze during daytime. So cooler air is coming on land, so hotness is not felt. So weather is moderate during daytime. Although it is hot surface, but weather is not so hot because of sea breeze. Now we get into night time. What happens in night time? Water, it cools faster and whole day it absorbs heat. It has lot of heat energy and it releases heat slowly for a lot of time. Still its temperature comes down very little. So when the daytime air over here is cooler, night time air is cooler now. During night. And here what is the situation here is hotter or warmer, purely. So now the convection current direction, it will be opposite now. So what kind of breeze it will be now? It is going from land to sea. So we call it land breeze. Okay. So at night you will have land breeze. So what is happening? When the cool air is going towards sea, the hot air is replacing it. So at night, instead of cold, you still have moderate temperature. So whether it is night or daytime, the weather near sea will be moderate. Okay, that's the first one sequence. Have everyone understood?
Yes.
Okay. Next.
What is the use for fermentation?
So what is fermentation? सेकना बोलते हैं, सेकना कुछ चोट लगी हो या फिर कुछ दुख रहा हो तो उसको क्या करते हैं? एक hot water bag आता है, सब घर में होता होगा, रेड हॉस्पिटल्स में देखा, water bag. So when you fill it with hot water, that bag remains hotter warmer for longer period. Because of high specific heat, you can use it for long duration. Okay? So that Indian term for it is called safety. I don't know if there is any other term for it. Everybody understood what is it?
Yes.
So again, this is because of, it is possible because of high specific heat. Third, read.
Water is used as an effective coolant.
Right. So coolant कहाँ पे use होता है? Engine. So उसमें क्या होता है? Whenever the engine is working, whenever the engine is working, so it becomes quite hot. Okay. So for its normal functioning, it has to be cooled. Right? So engine has to be properly cooled. So cool करने के लिए क्या करना होगा? देखो, let's say this is your engine. Let's say this is the engine. The engine, what does engine consist of? I told you, cylinder, piston, right? So cylinder and piston sits in, and this is then connected to a wheel which will convert the oscillatory motion or vibratory motion into circular motion. I have explained this earlier, right? So when the piston moves up and down due to expansion and contraction of gas, so it keeps on rotating, and this is connected to wheel through some. This rotational motion is connected to wheel of the bike or of the automobile. Have you signed the attendance? Which line? Okay. So when it continuously functions, this engine becomes hot, right? So in bikes, how it is cooled? It is air cooled, right? The stream of air cools it. But in bigger engines like car, truck, buses, right? So it has to be water cooled or you have to use some kind of coolant. तो coolant क्या करते हैं?
ठंडा करता है।
कैसे? तो ठीक है, इसमें क्या करता है? Each line is a. You can imagine each line to be a water line. Okay. ठीक है, water pipeline. So let us say the cold water goes from here. And the hot water comes out. Right? Through some mechanism, silence, pay attention, everybody. There is some provision to send the cold water around this coil. Right? क्या हो गया? Crisis. बाहर जाओ, crisis handle कर गया. Settled? Okay. So cold water is sent through the pipe around the hot engine, and this water now will absorb heat of the engine because it will absorb a lot of heat. Still, its temperature will not rise that much. So it has actually sucked all the heat from it with the help of this coil wrapped around it. Now, after absorbing the heat from the engine, this water will become hot. Then what is done is there is a fan, right? So this fan is running, and this coil is then passed through some mesh. Right? You must have seen. So in front of your car, There is a fan which is running, and that heat is now thrown to atmosphere. So that water inside the coil is again become cold. Understand? So this is how this functions. So it sucks heat from the engine, goes to the environment, it becomes cold, again goes in, out, and this cycle continues. Got it? Because you can't attach a cold water line and drive the car, so तुम्हारे घर से कार के साथ तो पाइप जाएगी नहीं. So this is the arrangement, right? Independent arrangement. In old days, we used to use water only to cool engines. Now we have specific coolants.
Yes.
Okay, so these are chemicals, but naturally available coolant is water. Okay, understood? So you don't have to draw this diagram and all. I just drew it just to explain the concept. Now, who's done?
In other countries, water is used as we reservoir for wine and liquor to avoid the
Aji,
Education system.
in cold countries, water is used as heat reservoir for wine and juice bottles to avoid the freezing. See, so if the atmospheric temperature drops and if these wine bottles and juices are kept outside, there is a possibility they might freeze. Okay. So what is done is because their specific heat may not be as high as water, so they may get their freezing point may be reached even before zero, right? So, but when they're kept inside water, then water is absorbing all the heat, or it is rejecting a lot of heat, so that the temperature around the bottle, okay, it remains high. Because water will become cool only after releasing so much of it. Got it? So that's why. So this actually helps you keep the beverages unfreezed, even at quite low temperature. Is it understood? So is it a consequence of high specific heat of water?
Yes.
But it is now the opposite example. Here we are trying to cool water. So it is not cooling down because a lot of heat has to be released by water to actually cool down by substantial temperature difference. Okay? So it works in both directions. Next. Read.
Farmers fill their fields with water to protect the crops from frost.
Yeah.
On a cold winter night, if the atmospheric temperature
Title समझ में आ गया? What does the title mean?
सर fields में पानी भर के रखते हैं।
उससे क्या होता है? Crop.
एक normal temperature
जो इससे पहले वाला टॉपिक था, इससे पहले वाले टॉपिक में क्या था? बेवरेजेस फ्रीज नहीं होता है। इसमें क्रॉप्स के अंदर जो जूस है, जो सैप आता है ना प्लांट्स में, उसमें भी वाटर होता है। तो जो कैपिलरीज है जिसके थ्रू सैप ऊपर आता है, वो तो कॉन्ट्रैक्ट होगी टेम्परेचर अगर डाउन हो रहा है तो, लेकिन जो सैप है वो तो वाटर है, वो फ्रीज होगा तो उसका वॉल्यूम इंक्रीज होगा। So it will rupture the capillaries. So plants will die. So to avoid that, fields are filled with water. Now, when the temperature drops, then water releases a lot of heat, so that the temperature around the plants remain in the safe. So it actually secures the plant's life. So sudden drop in the weather doesn't affect the plants or crops. Is it clear? So that's why during cold weather, the fields are filled with farmer fill their fields with water. Okay, sixth.
all plants and animals have a high content of water in their bodies.
Okay, so what happens because of that? The body temperature remains same during all weather conditions. So although the weather outside, whether it is summer or cold, lot of heat exchange, right? But your body temperature remains same, irrespective of the weather. Okay. Why? Because body is almost 80% water. Okay. Okay, so that was about water. Now about substances. So there are certain examples of high and low heat capacity, and what do we achieve out of it? Okay. Read.
The base of a cooling fan is made shape.
So base of the cooking pan is made thick. So boys, anybody who has done cooking? तो कैसा बर्तन यूज करते हो उसका बेस हम देखो
नॉन स्टिक पैन
कढ़ाई कढ़ाई वाले यूज करते हैं कढ़ाई का बेस क्या होता है मोटा होता है तो कौन सा ज्यादा टेस्टी होता है नॉन स्टिक पैन या कढ़ाई वाला क्या होता है food is tasty when it is cooked at a slow heat for a longer duration ठीक है if you suddenly cook anything right it won't give you that taste ठीक है it has to be cooked on a low heat for longer duration so when the utensil is thicker its heat capacity is more which means it absorbs lot of heat and then its temperature rises to okay so lot of heat energy is there and then it transfers that heat energy also when the heating is stopped even after that it transfers that heat for a very long duration. So once the food is cooked, the cooked food will remain warm for a longer period, right? If the utensil has a thicker base. As well as at the time of cooking, the cooking is slow and nice. That's all. Okay. So that's the so that it has high specific heat. The base is thicker, therefore the substance will have not specific, high heat capacity because the mass is increased. What is the difference between heat capacity and specific heat? So unit mass वाला specific heat तो उसका जो है वो है ही, but अब इसका mass बढ़ा दिया तो इसकी heat capacity है, got it? है ना? क्या हो? नहीं समझा? नहीं, अच्छा नहीं सर समझा हो, ठीक है समझ गया हूँ. Second, next, base of an so same reason जैसा पहले का है वो भी एक बार गर्म हो गया इलेक्ट्रिक so it will remain hot for very long time okay and you can press the cloth for longer duration और उसमें जो red और green light होती है so when the current is on so when is the current on when it is still getting heated so once the base is thicker right once it is off it will not be on again frequently ठीक है so this is what it is so you can press it for longer duration. Yes, your turn.
The vessel used for measurement of heat, that is calorimeter, is made of thin sheet of copper.
Yes. So, what is the advantage because of it? Why is calorimeter का जो copper vessel है made up of thin sheet? What do you achieve?
Does not take
So मैंने बोला था ना कि हम generally heat absorbed by copper vessel को ignore कर देते हैं unless it is mentioned in the diagram, right? So if it is thin, this ensures that the mass of the copper vessel is very less. Anyway, copper is a very small specific heat,
Yes.
which means even after absorbing little bit of heat, its temperature rises, right? तो बहुत कम heat लेगा वो mixture में, है? So to make sure that its heat capacity is further lowered by making it thin. Okay, is it clear?
Yes.
So we will come to solving numericals after we finish part B. Today we have only one lecture, right?
Small area lecture.
I think we might be able to finish it. Let's see. We have lecture tomorrow morning, right? 9 o'clock. So is everyone aware? We have lecture tomorrow morning at 9 o'clock. For 3 hours. You are running those kids. Attention everyone. Attention everybody. We have physics class tomorrow for 3 hours, right?
Yes.
Starting at 9 o'clock in the morning.
Yes.
I also came to know just now. Okay?
Yeah, 9 o'clock to 4 o'clock.
ठीक है चलो तो कल फिजिक्स मोस्ट लाइकली खत्म हो जाना है
Okay, sir.
This has been taught at your schools?
No, sir.
No, sir. Where has? Raise your hand जहाँ पे पढ़ा दिया? ये एक ही स्कूल में पढ़ा है? बहुत से स्कूल में है। Okay. So what are the phases or states of matter? Solid, liquid, and gas.
And plasma.
So you are not studying plasma. So restrict yourself in. That means you have solid, right? So how can you change the phase of solid from solid to liquid? क्या करना पड़ेगा? Heat it. When you heat it, okay. When you heat it, it will convert into liquid. Example, let us say you have ice. When you heat, it becomes water. Okay. Will it become gas also?
Yes.
When?
Sir,
When you heat it further, let's say I heated it and gave it energy Q2 this time. So when I heated it further, it now is converting into gas, which is vapor. Steam, vapor, whatever, water vapor. So we can achieve phase change or state change by heating. Okay. Is the reverse possible?
Yes.
yes.
So what is this process called? Meditation. This is called meditation. And what is this called? This is called revolution. Okay. What is the reverse process called? Yes. So this is called condensation. How will you achieve condensation? By cooling. By cooling. Yeah. Cool. How much? You have to remove the same amount of heat. Okay. When you heat it, whatever heat you have provided it, when you remove the same heat, then it will come back to its old state. Now,
The solidification.
this is called, this is freezing. Or fusion. Freezing is also called as fusion. Okay? Now, what happens during change of state? Does your body's temperature change?
No, sir. It remains solid.
Water remains at 0 degrees Celsius by itself.
Sir, temperature doesn't.
So how does the state change? What keeps solid a solid? What differentiates solid from liquid?
Entire bond.
Yes. Bonds are tighter in solid, right? And the molecules are closely attached. So when heat is given, now molecules are loose. That means they go away. What happens? Does the kinetic energy increase?
Yes.
Potential energy increases this time. That's why temperature does not rise. So the heat energy absorbed is utilized in breaking the bond. The molecules are now away. That's how solid converts into liquid. So when you draw the heat curve for ice, let's say draw the heat curve for ice. Huh? No. Hang on. So you're talking about ice, right? Yes. You want AC? AC चाहिए किसी को?
सर गरम गरम सर गरम हवा आ रहा है सर गरम
So everybody look here. Too much discussion going on.
सर जैकेट पहन ठंडी लगी
Pay attention, you know. So the y-axis represents temperature, x-axis represents time. Right? So heat curve of ice. We are making heat curve for ice. So let us say the temperature here is 0 degree, 5 degree, 10 degree. And now we make a discontinuity. Let's say this is like 75 and 100 degree. And now let us say we are heating it for sufficient time. Okay. Let's say we heat it for 20 seconds, 40 seconds, 120 seconds, 160, so on and so forth. Right? 5 minutes. This is minutes. This is temperature in degrees Celsius. Can you see the discontinuity in the graph? What does it mean? So the scale may be different later on after the discontinuity. So here it is like 1 unit is 5 degrees, 10 degrees, right? After this 25, 25. Okay. And here it is like 2, 4 as a 4 level. Out here 1 unit is 20 seconds. And then after discontinuity, each unit is 2 minutes. That is. So what do I get? Right? Let us say when I'm heating ice, initially what was the temperature of ice when it was solid? 0. So what I observe is I have put a thermometer in a vessel where I'm heating ice. Okay? So that thermometer shows 0 degree only. So initially I see ice, later on I see ice and water, and then I see only water after some time. Okay, full ice is melted, but the temperature shown in the thermometer is 0 only. So now the phase is changed from ice to water, but its temperature does not rise. If I continue to heat, so I must have given some heat here. That heat I am calling Q1. Okay. Later on, when I see now the temperature is rising. Okay. Now the temperature is rising, and it rises till 100 degrees. So this is the heat curve of ice. It rises till 100 degrees. Okay. If I keep on heating it, then what I get is again the temperature does not rise. Now the water has begun boiling. So from here to here, when I heat, that heat is different. Again from here to here, that heat is different. Okay. So what is happening when I'm in the first part? So this graph is divided into, let's divide it further. If I continue to heat it further, then you have Q4 also. So can you tell me what is happening here in the first region, in the second region, third region? and the fourth region.
Sir,
What is happening in the first region? Venting going. So the state is changing from solid to liquid. So during phase change, the temperature does not change. So temperature is constant. Got it?
Yes.
Then once it is converted into water, if I further heat it, the temperature of water will rise till it begins boiling. So till 100, it will rise. Thermometer will show rise. Once it reaches boiling, now again it is flat. The curve is flat. That means at 100, its temperature is not rising. But it is absorbing heat. So what is happening? Liquid to gas. Okay. So that is why Q1 and Q3 has a different name. What is Q1 and Q3? It is called latent heat. Because right now it is the substance is absorbing heat, but it is not reflecting in terms of change of temperature. Normal case में अगर किसी substance को heat करते हैं, तो उसका temperature बढ़ जाता है. But यहाँ पे temperature में कोई change नहीं आ रहा. That's why it is called latent heat. Okay. So Q3 is also latent heat. Which latent heat? Latent heat of vaporization. This is latent heat of fusion. So, because Q2 is same during freezing or during melting, so its name is given as latent heat of fusion. And here we call it latent heat of vaporization.
So can we say that latent heat is the heat that is required for changing the state of a substance?
Yes. That's right. So this latent heat is the energy needed to change the phase or state of the. That's it. But is it constant for a given substance? So it is just like heat capacity. So what is constant? Specific latent heat. How you fix the unit mass. So heat energy needed by unit mass of the substance to change its state. That is specific latent heat. That is a constant for a given substance. Okay. So now we define what is called as specific latent heat. Right? What is specific latent heat? So it is the amount of heat absorbed by unit mass of a substance. Okay, this is the specific latent heat. So it is given by formula L is equal to mu by M. Are they different than specific heat? Just delta T is the same. There is no change in temperature. That's why it has only heat per unit mass. So what is the unit? Everybody understood? So there are two types of L. LF will be latent heat of region, specific latent heat of region, and LV will be latent heat of region. Same formula, right? Just the Q1 and Q3. That's it. And what is the formula for Q2? What kind of heat is Q2? Very good. Sabash. Because now what is happening? There is a change in temperature. Okay, so this will utilize specific heat of that substance. देखा ये है तो हीट कब से समझना है किसी भी न्यूमेरिकल में उसका हीट कब बनाओ उसका क्यों डिसाइड करो then add it on so it won't be subtraction Q4 भी वैसे ही होगा Q3 and Q4. Q4 also. चलो, ठीक है. Q4 will need specific heat for steam.
Yes.
And Q3 will use, Q2 will use specific heat of water. That's the difference. Mass and delta T will be same. Not same. Different. Temperature is different, right? So this delta T here will be different because it's different temperature. Over there it could be different. All right. Any questions? Concept wise, we are done with this chapter. There are only, yeah, it's very easy to understand. So, if I ask one of you draw heating curve for water, can you identify where is heating curve for water in this?
Just from
Heating. Heating of water. Water से steam नहीं पूछ रहा. Water है. Then heating of for ice. वो कॉमन. इसके बाद में एक फेस चेंज दिखना चाहिए. यहाँ पे वाटर से स्टीम, यहाँ पे आइस से वाटर. ठीक है ना? यहाँ पे क्या हो रहा है? यहाँ पे वो वाटर और स्टीम दोनों है. यहाँ पे फुल्ली स्टीम हो गया. ये एंड पे. ठीक है? यहाँ पे फुल्ली वाटर हो गया. यहाँ इधर आइस और वाटर दोनों है. You understand? During melting stage, it is ice as well as water. It converts completely into water at this stage. Okay? Same case here. The water starts boiling. You will see boiling water here. Some of it is evaporating. Water and steam will be seen together. At this point, it is completely steam. पूरा water convert होके क्या हो गया? Gas हो गया. यानी अगर प्रेशर कुकर है तुम्हारे पास ट्रांसपेरेंट, ठीक है, ट्रांसपेरेंट, या तुमने कुछ प्रोविजन किया है कि उसका अंदर क्या चल रहा है वो ब्रॉडकास्ट हो रहा है स्क्रीन पे, लाइक ठीक है. कुकर के अंदर क्या हो रहा है? You will see that at this temperature over here, it is completely steam. There is no more water left. Okay? Now it's the effect. Any questions here? No, sir. Next. क्या होता है? Ice. क्या होता है बोलो? So when the pressure increases, melting point increases. So होता है क्या? Pressure increase. Water के केस में या वाटर के केस आई से वाटर क्योंकि वाटर हैज एनोमलस बिहेवियर इसलिए ऐसा आपके केस में नहीं होगा जो सब्सटेंस फ्रीज होने के बाद जिसका वॉल्यूम एक्सपैंड होता है ना उस केस में ये ट्रू इट इज ट्रू ओनली इन केस ऑफ वाटर अभी तो प्रेशर डिक्रीज का केस ठीक है तो तो बता रहा हूँ ये मैंने बोला ये रिलेटेड है एनोमलस बिहेवियर सब्सटेंस expand on freezing like ice water का क्या होता है ice का वॉल्यूम water at 0 डिग्री से ice at 0 डिग्री is always bigger ice expand होता है ना are you sure नॉर्मल केस में क्या होता है किसी भी सब्सटेंस को जब कूल करेंगे वो कॉन्ट्रैक्ट होना चाहिए लेकिन आइस के साथ ऐसा नहीं है वाटर आइस होती है एक्सपैंड होता है ठीक है ना वैसे सब्सटेंस जब हम प्रेशर इंक्रीज करते हैं तो उनका मेल्टिंग पॉइंट इंक्रीज होता है फिर वैसे वाटर इज स्पेशल केस व्हाई आर वी डिस्कसिंग इट क्योंकि एक्सेप्शन ये एक्सेप्शन वाटर समझ आ गया अच्छा अब बॉइलिंग पॉइंट में क्या होगा प्रेशर इंक्रीज होगा तो बॉइलिंग पॉइंट डिक्रीज होगा सॉरी इंक्रीज होगा ठीक है प्रेशर इंक्रीज होगा तो बॉइलिंग पॉइंट क्या होता है इंक्रीज होता है और बाकी वाइस वर्सा एंड वाइस वर्सा यानी ये जो है उसका उल्टा होगा प्रेशर रिड्यूस हुआ तो मेल्टिंग पॉइंट इंक्रीज होगा वाटर के केस में हम बात कर रहे हैं स्पेसिफिकली ओनली फॉर और बॉइलिंग पॉइंट में प्रेशर अगर रिड्यूस हुआ बॉइलिंग पॉइंट क्या होगा वो भी रिड्यूस होगा इसलिए व्हेन यू गो टू हिली रीजन प्रेशर क्या होता है एटमॉस्फेरिक प्रेशर रिड्यूस वाटर का बॉइलिंग पॉइंट कम हो गया and instead of boiling at 100 degree it starts boiling at 70 तो बॉइलिंग मतलब इवेपोरेशन शुरू हो गया यानी फूड पका नहीं और वाटर इवेपोरेट हो गया समझेगा तो ये होता है सो बेसिकली जब प्रेशर आपका लो होगा तो बॉइलिंग पॉइंट भी लो हो जाएगा है ना that is when pressure reduces boiling point also यहाँ पे क्या होगा प्रेशर reduces melting point ये चीज समझ आ गई फिर एनाबोलिक बिहेवियर जहाँ पे होता है जैसे कि वाटर का है तब ये ट्रू है बाकी सबके लिए ऐसा नहीं ये सबके लिए सेम है क्योंकि यहाँ पे एनाबोलिक बिहेवियर नहीं है वाटर का यहाँ पे जब भी प्रेशर बढ़ेगा तो बॉइलिंग पॉइंट बढ़ेगा ही बढ़ेगा जब प्रेशर कम होगा तो बॉइलिंग पॉइंट भी कम हो जाएगा सबके लिए ओनली एट दिस जोन फ्रीजिंग जोन में वाटर के साथ उल्टा होगा ठीक है तो ये समझ आ गया नेक्स्ट इज इफेक्ट ऑफ impurity on melting point and boiling point of water देखो इसको वाटर ही बोलते हैं बिकॉज आइस भी वाटर का सॉलिड फॉर्म समझ आ गया तो जब भी मेल्टिंग पॉइंट ऑफ वाटर बोल रहे हैं समझ लो आइस मेल्ट की बात होगी अब हमने क्या करा आइस में हमने क्या कर दिया नमक मिक्स कर दिया सॉल्ट क्या होगा उसका मेल्टिंग पॉइंट रिड्यूसेस बाय ऑलमोस्ट 20 to 15 डिग्रीज मतलब ice will now melt at minus 20 degree. Meaning ice will convert into ice cold water whose temperature is minus 20 degree. So water is minus 20, but it's not frozen. When ice is next. You understand? So where can it be used? Making kulfis. Because kulfi तो बर्फ आप जैसे बर्फ में सॉलिड बर्फ में कुल्फी क्यों नहीं बना सकते? क्योंकि कुल्फी का शेप होता है ना, जो कंटेनर होता है, तो आइस में वैसा ड्रिल करके थोड़ी ना कंटेनर रखते हैं. So if the water, if it is that cool temperature is achieved in liquid form, then you can just dip the container, and the contents of the empty will then be processed. Yes. पहली बार में करी समझ. देखो अगर आइस का मेल्टिंग पॉइंट क्या है 0 डिग्री सेल्सियस. तो आइस जब मेल्ट होता है 0 डिग्री पे तो हमें जो वाटर मिलता है उसका टेम्परेचर क्या है. अब मैं बोल रहा हूँ आई हैव अ ट्रिक टू रिड्यूस द मेल्टिंग पॉइंट ऑफ आइस टू लेसर टेम्परेचर. लेस देन आइस तो minus 60 डिग्री सेल्सियस तो भी आइस ही है. So let us say I have now ice which is at minus 20 या minus 60 डिग्री. अब मैंने उसको क्या करा, इसमें नमक मिक्स कर दी. अब मैं उसको हीट कर रहा हूँ. ठीक है, now I'm heating ice. तो कब मेल्ट हो जाएगा? minus 20 डिग्री में मेल्ट हो जाएगा. क्योंकि मैंने इसमें सॉल्ट मिक्स किया, इम्प्योरिटी मिक्स किया. तो इम्प्योरिटी मिक्स करने से मेल्टिंग पॉइंट ऑफ आइस रिड्यूसेस. अब वो minus 20 डिग्री में मेल्ट हो गया. तो मेरे को लिक्विड फॉर्म मिला. वो लिक्विड का टेम्परेचर क्या है? Which is less than freezing temperature. Freezing normal substances. इसमें वाटर है वो 0 भी होता है. कुल्फी के अंदर भी वाटर तो होता है. वो कुल्फी को जमा देंगे. क्योंकि उसको बाहर से टेम्परेचर क्या मिल रहा है -20. कंटेनर में कुल्फी मालूम है? हाँ सर. तो जलेगी कैसे? आइस जमाने के लिए तो तुमको आइस को तोड़ के ऐसे अगल बगल पैक करना पड़ेगा. आइस में होने को 0 डिग्री मिलेगी. That कुल्फी will not be pretty warm. क्योंकि जैसे ही वो 0 डिग्री आइस जो है 0 वाटर तो बाद में वो गर्म हो जाएगा. कुल्फी अच्छे से जमा भी नहीं पाएगा. So we need water which is less than 0 degree, but it is water form. समझ गए सब लोग? Okay. Now, so by adding salt, ice melts at minus 20 degree Celsius. Celsius. This is used in making this example is given in your book. The salt is impurity. ठीक है, salt is impurity. अब इसका असर boiling point पे क्या होगा? यानी pure water will boil at 100 degree Celsius. A salt added water will boil at 110 or at a higher temperature. That is why food is cooked better when it is not boiled in pure water but in salt water. ठीक है, ज़्यादा टाइम तक हीट लेने के बाद फिर वो बॉयल होना शुरू होता है. ठीक है, हाँ ज़्यादा देर इवोपोरेट देर से होता है. इवोपोरेट देर से होगा. By adding salt, That's it. So, और नाम बोल रहा